All right, good morning, everybody. Welcome to week 13 of CNET58. This morning, we're going to have a lecture and a lab, and we're going to look at mail servers. So the killer app of the internet was really email, and I've got some statistics to kind of show some of that. So it's really interesting, the history of the email server. So how's everybody else doing? I know, Ian, you said you're feeling the effects of the second shot. Hopefully that passes quickly. Anybody else? Awkward pause. Okay, so Frankie told you that the second shot, the side effects go away after a couple days, so that's good. All right, well, let me share my screen and get things going here. All right, so here's our course, right? CNET58. Scroll all the way down. We're almost to the bottom here. And I just published week 13. And we're going to look at this CNET58 mail service.PowerPoint, the lab 12. And I have created a video. So I went through the lab and I did a step-by-step video for you. So if you get stuck, or if you want to, kind of see the steps in action other than just on the page with screenshots like I normally do in the lab, here's a video where I kind of walk through it. So let's go to this week's PowerPoint, and I'm going to share the PowerPoint. I like doing that. Get to it. And, all right, so you should be seeing my PowerPoint here in just a minute. It has to prepare it for sharing. And let me make this full screen. Move the speaker top left. All right, so I mean, if you were talking to somebody and you were to ask them, what is the main form of communication that they use with regards to some sort of internet technology, the majority of people would probably say, and feel free to, insert your opinion here or your idea, but they would probably say that if they have a quick communication, they're probably going to use some sort of messaging, right? Like a text message, an SMS message, or some sort of messenger. I don't even know if those are really that popular anymore. Like Facebook Messenger or Google Chat or any of those. But for a quick one or two, like, hey, where are you? I'm pulling in, to Starbucks right now. If you're meeting somebody, you might get a text message like that. But if you need to communicate with somebody that may not be as instantaneous, maybe you just want to ask something and have them respond with some sort of insight, a little more than just a sentence or two, email is still the main way of doing that, right? And because of that, IT professionals like ourselves, we need to be able to work with mail servers and set them up, build the environment around them, make sure they're secure, make sure the mail transmissions are secure, and so forth. So really, that's what we're going to look at today. Now, today's lecture is not going to last very long. I mean, it may go an hour and a half to 2 hours at the most. And then after that, I'm just going to turn you loose in lab. So this is on mail servers. That's what we're going to talk about. It's not an overly complicated technology. It doesn't take a lot of time to kind of get things set up the way we want them to, but it does have a couple of steps that you have to do in the right order. Otherwise, troubleshooting and coming back to it can be kind of difficult. All right, so let's get started. So here's the mail button, right? Wouldn't it be nice if there really was a key on your keyboard that, press that and then it just communicates whatever you're thinking or whatever you can speak, and then it sends an email. It'd be nice. So when we look at this, we're gonna kind of break this lecture into 6 areas. And the first one is going to be what exactly is email? And then what makes up email? What are the ports and protocols of email? What are the Windows email solutions? What are the Linux email solutions? And then how does the cloud play into all this? All right. So that's what we're going to spend the next couple hours looking at. Now, the history, and if you do a quick internet search for the history of electronic mail, you may get some information that's different. I chose to, say that some people say that the Morse code or the telegrams are the original electronic email because they really did send text from one person to the next. So if you've ever seen the wires, the cables that were run across the United States, really, especially in the Western United States when it was first kind of being settled, there were, stations set up about a day's horse ride away. So, some people say that was maybe 50 to 75 miles. And every day's ride, there was a mail station for the Pony Express. And at those stations, they had run wires above the ground, just some small gauge wire, and they could send Morse code and telegrams on those wires. So they were quick, like text messages that took, weeks to get there or to get to the right people. Now, there's an estimate that approximately 28% of a typical office worker, 20% of their day is spent dealing with email, right? Either responding to emails or writing emails or scheduling some sort of meeting or task list in email. So the email client and the email system is very, very important. I mean, even though we probably think of it as an afterthought, it really is a very, very big part of it. So how did it start? So in 1971, this United States programmer, guy named Raymond Tomlinson, allegedly sent QWERT UIOP, which is just the top of the keyboard, right? Underneath the number keys, as the first network email. And he was the first to connect his computer to his mailbox using the @ sign, right? The shift 2. So he was he's credited with creating email. And in 1977, Tomlinson's emailing method worked for network computers using the same software but many people began using the Department of Defense ARPA net, right, the Advanced Research Projects Agency network, to connect outside networks. So you have to remember, at this time, there wasn't a backbone to the internet. There were really only 5 nodes or 5 connections, 3 of them in California, or 4 of them in California, and 1 of them in Utah. And it was designed by the Department of Defense to allow communication in the event that the regular communication systems went down. So it was the start of the internet as we know it. So I'm gonna click on this link here, and so let me get this link open. And hold on, I need to stop this share. And share this way. Okay, so all right, so let's watch this short video about email after we hear about Google Fi.
At first, there wasn't much to do on the ARPANET beyond transferring data files among its members. But then a new capability was added, the first killer application that would bring in the masses and take the usefulness of computer networking to a new level. That killer app was email.
I was actually working on a mail program, but it was programmed for a single computer so that you could send messages from yourself to another user on the same time sharing computer. And I had written a couple of programs to transfer files, and it occurred to me that since the mailbox that I was sending these messages to was nothing more than a file, I could send that file across the network instead of keeping it within the same machine. And so I put 2 programs together, modified the code a little bit, and the first email program was created.
Tomlinson did more than just write the code for email. In a keystroke, he gave the world a new icon for the information age, the @ sign.
The @ sign was the most obvious choice because we're talking about a user who was at some computer. It just made sense.
Ironically, what would become one of the most popular applications on the internet was a program Tomlinson wrote on his own time.
It seemed like a neat idea. Nobody was clamoring for email. And there's nobody, our sponsor, Department of Defense, didn't say anything about wanting email. My boss didn't say anything about email. But in fact, nobody said anything about email because the term wasn't coined until several years later. But it just seemed like an interesting thing to do with a computer and a network. And so I just did it.
So then electronic mail became the completely unanticipated killer app, as we say, for the ARPANET. We went from remote login, file transfer, electronic mail in a year flat or 2 years flat. And then it stayed that way for 20 years.
All right, so that's the killer app of the internet with Tomlinson, and he started. So in 1981, so probably none of you were born in before 71, 77, 81, 85, 91. So some of you are probably going, this is some ancient history, but it's not that long ago. And in 81, the ASCII adopted a process of letters, punctuations, and symbols to digitally store information. So the ASCII code was developed in 81, and that was a big part of sending the data. And then in 85, the government and military employees, students, and academic professionals were common email users in the mid-1980s. And then In 1991, ISPs allow widespread internet access, but there were limited options for use until Sir Tim Berners-Lee created the World Wide Web with the Hypertext Transfer Protocol, HTTP, in 1991. So email was there, but the World Wide Web, the internet browsing and the capabilities of the internet as we know them today were not there yet, okay? So in 1993, IDM and Bell South marketed the first PDA, which is the personal desktop assistant, functioning 20-ounce cell phone, which sold for $900 and served as a phone, a calculator, a fax, email device, and a pager. So that was in 93. In 1997, Microsoft purchased Hotmail for $400 million. And do any of you still have a Hotmail email address, right? Some people still do. And then in 1998, the romantic comedy with Tom Hanks and Meg Ryan, You've Got Mail, was released. And the beginning of that movie, it kind of speaks to all of us in that when you would log on to AOL, the first thing you were kind of hoping for is you would hear that ding, you've got mail notification, right? And it kind of was like the dinner bell for Pavlov's dog that trained us to anticipate getting email. And, you know, it's just a standard start your day practice, right? You get into the office, you log into everything you need to log in, you know, you maybe, you know, adjust your lighting, turn on your music, or, you know, whatever you got there, warm up your coffee, and then you start looking at your emails to see what's going on today. What do I have to deal with, right? And that's kind of the tradition for most workers is, you know, you get on your email and see what's up. Okay, and then in 2003, the RIM 850 and the 857 original BlackBerry smartphones were released, which revolutionized the mobile platform by concentrating on email. And around this time, very few people had smartphones. There were no smartphones. There were just BlackBerries. And BlackBerries were a status symbol of executives and the movers and shakers in companies, because they're the only ones with BlackBerries. So if you saw somebody, you know, in Starbucks, which was just starting around that time too, and they had a BlackBerry on their hip, you right away, at least the people that knew anything about it, realized that this person is a high roller. He's a bigwig at his company, because they were the only ones that had that kind of technology. Now, I mean, go to McDonald's and go in the play area, and you'll see 6-year-olds with better and newer iPhones than you and I have. I mean, talk about a change in, you know, accessibility. Who has access to technology? Now it's everywhere. But in 2003, the BlackBerry was there. So here's the BlackBerry with the full keyboard, right? And these systems were, it was an add-on. You had to have a mail server on your site, and then you had to buy the BlackBerry licensing that added software to your Exchange server, if it was Microsoft, that allowed your BlackBerries to communicate with them. And they're very popular. And in fact, in 2004, President George W. Bush signed the Controlling the Assault of Non-Solicited Pornography and Marketing Act of 2003 into law, which gained criticism because it did not stop spammers as aggressively as some people had hoped. And imagine if he had been a little more aggressive against spam, maybe it wouldn't be as big a deal today. And we're going to talk about spam in a few minutes. And then in 2008, when President Obama took the Oval Office and became president, he admitted that he was addicted to his BlackBerry. And despite security concerns, he continued to use it while in office, right? The White House at the time, they said, hey, we really don't want you on your BlackBerry. We need you to use our secure phone system and our secure messaging apps. And President Obama said, you know what, I'm gonna stick with it. Now, we could probably trace that back and say, had they been a little more firm with him, maybe the next president wouldn't have had a problem with Twitter. I don't know. But so you can kind of see how there's history here. In 2011, there was a study that finds the worst email passwords are password and 1, 2, 3, 4, 5, 6. So when we talk about password security, if one of your passwords is the word password or 1, 2, 3, 4, 5, 6, I encourage you to go change it, right? Go get on that system and change your password. Other worthies of note were QWERTY, Monkey, and Let Me In. And then 1, 2, 3, 4, 5, 6 was also the most common password during a 2012 email hack. And then in 2012, there are more than 3 billion email accounts across the globe. So this is like almost 10 years ago, 3 billion email accounts. And the world population at that time was probably just over 5 or 6 billion people. Now it's around 7 billion. So almost half of the planet had an email account. And that's probably not true to say, because there's many people that have multiple email accounts. So it may not be 3 billion unique people. There's just 3 billion email accounts. And approximately 294 billion emails are sent per day. And out of those 294 billion email messages, a little over 3/4 of them are spam. So let's take a look at this link. Oh, we're not going to take a look at that link. But there was a project in early 2007, 2008, where Google had a project called Google Wave. And I want to, hopefully this one is there. Let's see. Yeah.
What's all the fuss?
So this is a video that came out in 2009. And Google is notorious for starting these projects. And they sound really cool at the beginning, and then they just kind of disappear, right? Have any of you used some of the Google systems, and then all of a sudden one day you log into it and it says, sorry, this service is no longer available? Google Wave was an idea that I know that the people that were on Google Wave, they got on other teams and they incorporated some of these ideas. So let's watch this real quick.
About Google Wave. If you're like me, you've used email for close to 15 years, and you may have noticed that sometimes it breaks down. Like, take this experience, for example. Say you email your web guy and say, hey, can you get that new website functionality A, B, and C up and running? And then your web guy replies, oh yeah, bro, no worries. I got A, B, and C under control. And so you CC your boss so you could watch what's going on, and then you reply, oh yeah, and here's that list of bugs that we found. And then he's like, oh yeah, no problem. Here's that password to that thing that you can check out when you have time. And you're like, sweet, and here's that attachment. And then you realize that you should forward this whole thing to your video guy so he can catch up on what's going on. He gets this mess of an email that would take a programmer to encode, and he doesn't reply all, so it creates another version of this thing. And everyone keeps posting and highlighting their answers to certain questions and the replies. The whole thing just starts mutating into this monster thing. Did you know email was invented 40 years ago, the same year as the lava lamp. So Google set out to rethink email. They took all the best features of these new communication innovations and they asked, what would email look like if it was made today? Instead of emails being passed along, Google Wave is a hosted conversation with only one copy that anyone can contribute to. So I can write A, B, and C functionality that I want to see happen in this website. And then I can invite my web guy to the Wave, and I can invite my boss too. And if we're online at the same time, I can actually see his replies in real time. He can drag and drop attachments. And then later you can invite the video guy and he can replay the whole conversation with the playback tool to catch up. It's all really slick and convenient and not at all a monster. And that's like 3.5% of what Google Wave can do from what I understand. You know, just kick it, grab a margarita and watch your communication-ness soar. If I can only get an invite, that'd be great. So come on, Google. Give me an invite.
So that is referring to you had to be invited to some of these new technologies that Google had. And then once you had the invite, then you could invite other people, and it was kind of a way of making something go viral in a lot of ways. Now, if you looked at that, some of you are probably thinking, what that just looked like is what Google Docs does, right? When you collaborate on a document, all that stuff that can be included in there, including the chat, including the transcript, including all that stuff that is common in communication processes now. Just like, you know, we're recording this video and it has some of those elements built into it. All right. So the electronic mail or email is a system for receiving, sending, and storing electronic messages, right? One of the key features of email is the ability to search and find archived emails. How many of you have been working with somebody or talking to somebody and you use this statement of, I have an email with this information in, let me see if I can find it and I'll send it to you, right? We do that all the time, right? That's just a common everyday occurrence. You know, when I'm meeting with people or on a committee or something, that must come up, that exact sentence, 20, 30 times. So messages sent by electronic mail normally reach a recipient's email account within seconds, right? How many of you, when you send an email and you're on the phone or you're, video chatting with them, and you say, did you get it? And they're like, no, not yet. Yeah, there it is. Just got your email. I mean, it's like instantaneous. Now, email messages can contain way more than just text, right? It's a file transfer method. So a lot of people, they'll say, well, let me send you this file via email. That's how they share files, right? Instead of saying, well, let me put it on Dropbox and send you a link, or let me put it, if it's an Adobe document, Adobe will say, do you want to use Adobe Cloud? And those kind of things, we can still just send it. And the email address is still represented the way Tomlinson created it 40 years ago. So back in the early to mid 70s, and it hasn't changed at all. And when we set up our accounts today, we're going to use that same system. So we normally have the account is broken down into the username at the user computer. And this user computer has changed to the username at the user's domain, right? So like we're going to use user1 at cnet.lab or kmiller30 at mountsac.edu, right? The username and then the computer name and or the domain name. Now, today, there are over 4.35 billion email accounts. That was predicted to reach 5.59 by 2019, which is still a 26% growth. So there are 2.586 billion email users worldwide, including both businesses and consumers. 122 billion emails are sent every hour. So there's a lot of traffic that goes through our mail service. 81% of US online shoppers are more likely to make additional purchases either online or in person as a result of emails based on previous shopping behaviors and preferences. So you combine this with some good old spyware, and you know what spyware is, right? It's where they look through your cookies and your browsing history, and they make suggestions based on what you're interested in. And if they send an email, so let's say you've been browsing for, you know, a new golf ball, right? You've been looking at the new, you know, Callaway Chrome Soft, whatever golf ball. And so you go to Amazon, you look at it, you go to golf.com and you search for it, you go to Golf Spy and you do all these review stuff, but you're not really sure, I'm not gonna, you know, spend $40 for a dozen golf balls today. And all of a sudden, within minutes of you getting off of the internet, all of a sudden you get an email from Callaway that says, introducing the new Chrome Soft golf ball membership program, where now you can subscribe, and this is a real thing, you can subscribe to golf balls, where they'll send you a dozen golf balls every month, every 2 months, for X amount of cycles at a subscription fee, right? Just like we subscribe to, you know, Netflix and all that. They're doing that now with golf balls. I kid you not. So if an email comes at the right time, it may induce you or encourage you to actually click on the link and make the purchase. So shopping, especially online shopping, is a psychological experiment. We're the product, and you know, we're the test subject, and all this stuff is going on that will kind of make it, you know, and then we're like, yeah, I decided to buy something. And that's probably not the case at all. You were coerced or you were psychologically programmed to buy that or to make that decision. Okay. Now, 55% of companies generate more than 10% of their sales strictly from email. So when a company sends you an email, and you know, I have an annual task list. So normally around November, once the weather starts getting a little colder, I decide that's when I'm going to go through and start unsubscribing all my email messages. So, you know, during the year when you sign up, especially when I'm always looking at products like, you know, last week with that honey pot, right? I have to go download that because it's only good for 30 days and then put it on our file share so you can grab it. But that's only 30 days. So every year I have to sign in, give them my email address, and then request a download of it. And then I start getting emails from that company. So that KF sensor that we used last week. So that's a good example. And then, you know, I do that a couple hundred times. Before long, near the end of the year, I start having, a couple hundred emails in my inbox every morning from all these different places that I really don't need communication from. So I'll go in and unsubscribe, 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 and whittle down my email address. But 55% of companies generate more than 10% of their sales from email. So this, just think if you were a company, and generally we think of sales departments where they're sending salespeople to sites, right? They'll send their sales force to go meet with clients and hopefully convince them that they need our product. Well, with email, you can hire an email consulting company, and they can generate the traffic for you and send it, and all of a sudden your sales go up 10%. That's a good return on the investment to do that. Now, some of you may have, when I first started talking about email, you might have said email is an ancient technology. Its day has come and gone. Well, email may not be as dead as we thought it was. Now, unlike other communication media, email is the last great unowned technology. So this means that nobody owns email. There's a lot of talk about, big tech and government oversight and control over, who gets censored or not on email, right? Or on big tech, right? Facebook has control over that. Twitter has control over that. Instagram, all of these social media companies, they can do that because they're privately owned, right? The company owns that, so they can kind of dictate their user agreements and what is considered acceptable and unacceptable. And I'm not here to, talk about that as far as this is right and this is wrong. I don't know the answer to that. But email is unowned. Nobody owns email, just like nobody owns the internet, right? So in a lot of ways, email continues to be in the background compared to some of those other technologies as far as popularity or buzz, but it still remains available, and it's not going to easily be censored by anybody. Okay. Now, it's estimated that an office worker will check their inbox an average of 77 times a day. So just put that into context. A typical workday is 8 hours. That means you're checking your email 8 times per hour, which breaks down to once every 7 or 8 minutes. So every 7 or 8 minutes, somebody will open their email and see if they got anything, right? And it's hard for some people to resist when they're doing something and all of a sudden they notice that they got an email. It's hard for them to resist not looking at it. Just like our phones, right? When we're in a conversation with somebody and all of a sudden our phone dings that we just got a text or we got, something from something, we want to check our notifications and see what's going on, right? And that conditioning, that mental conditioning, that psychological conditioning started with email. Okay. So email is, from a legal standpoint, and again, remember, I'm not a lawyer, but from a legal standpoint, email is generally treated as a private form of communication, much the same as a phone call or even a handwritten letter The specifics will vary from one country to another, but it is typically illegal to access, read, or publish another person's messages without permission. So a lot of companies will have a policy that will state that they have permission to monitor the messages sent from or received at corporate email addresses. So if you use your student.mountsac.edu email address and you're sending something, say hate speech or, bomb making recipes or, anything that would be considered hazardous or detrimental to the college has the ability to tap into your email account. Now, the fact that it's hosted by Google, I mean, let's not be naive and just state it obviously. Google can read our email. Google has said they monitor email messages, right? They're looking to and they may not do it on a persistently aggressive method or way, but they can casually read and view the content of users' email. Just like, Microsoft can do the same thing, and any other large email provider can do that. Companies also have that capability. When I was an IT director at another college, I was asked one time by the president to monitor and send a user's email messages to the president. He wanted to kind of keep an eye on this person and see what they were saying. And it was in our handbook. It was written, everybody signed when they hired on, and then every couple of years when HR would modify the handbook, everybody had to consent to this. And it would state the company, the administration has the ability and the legal right to view your email messages. So, if you're going to send anything detrimental, now in this case, it wasn't illegal. It was just kind of, some personality conflict stuff. I mean, it was resolved, personally, but the ability to deal with that is there. Okay, so we have to be aware of that. If you're using a MountSAC email and you're saying sending emails about another student or another professor or about the college or about a policy or about, just be advised that those messages, and I'll use the word may, be observed. So you always just want to, and we're going to talk about email etiquette later on as well. Okay. Now, another privacy concern is that every electronic message becomes a more or less permanent record of the communication. So if I send an email and I go into my sent items and I delete it, woo, it's gone, right? Nobody can ever find that message again. No, that message is going to be on every email server and every router and every log server that it goes through. So if I send an email from my KMiller30 account at MountSAC, it's going to go through MountSAC's email server. There will be a copy there and a log of it. And then it's going to go, let's say I send it to somebody at, citruscollege.edu. It's going to go through the ISP's routers to get to Citrus. And then it's going to go to their mail server where there'll be a log of it, and then to the user account. Now, if they delete the message, it's still in between. Even though I delete the sent message, they delete the received message. There is still a footprint of that can be used as evidence. Okay. So deleting an email does not necessarily mean it's gone for good. You know, unlike a paper message where, you know, like in Mission Impossible, right? They would get their messages and then all of a sudden it'd say this message will self-destruct in 5 seconds. And then poof, it catch on fire and, you know, burn up at the end. And then it's gone. I mean, there is no message of that. So it is considered unwise, and that's an understatement, to send sensitive information via emails as it can be intercepted. Now, we can scramble the writing by using encryption techniques that will prevent somebody from being able to view the content of our email. And that provides what we call confidentiality. But that has to occur in order for that to be effective. Now, the US Post Office handles approximately 485 million pieces of email per day. That sounds like a huge number until you realize in that same amount of time, there are 40 billion email messages. So, you know, when's the last time you received or sent actual mail through the US Post Office? Like, how many of you decided, well, I'm going to write grandma a letter? So you get out your pen and your paper or your computer and you type it and you print it and you sign it, you know, and you stick a picture in there, or you know, if you're writing, you know, your grandkids or whatever, hopefully they put a check in there for your birthday, right? For your graduation. Now it's the graduation season, so you're getting a lot of that. But and they mail it through the post office. But the reality is 40 billion. So, you know, 100 times more messages go through email than through the post office. So that's what email is. Now, how many of you can remember your first email address? Anybody? Okay, Frankie, in 2012. Was it on Gmail? Yeah, a lot of people's, especially your generation, Yahoo. Yeah, I still have a Yahoo email address. But you know, a lot of when you look at somebody's email address, you know, it may say, you know, scaredy cat 1999 or whatever. So, you know, when we're young, we don't really think of really cool email addresses until we get older, or we want more generic email addresses. So there's a thing, and those of you that have taken the Tech 60 class with Professor Uranga, he talks about this when you start sending emails and cover letters to prospective employers. Send it from a professional sounding email account. You know, if you have an email account that is, you know, Ichabod Crane 2012, or, you know, some weird email address that doesn't really describe you at all, don't send that to an employer, because they're going to look at it and go, this isn't very professional. Now, if it says kmiller@gmail.com, or, you know, whatever the number might be behind it, that looks more professional. At least it has your name in there where they can say, oh, this matches this resume or this cover letter. So it's going to be a little more on the professional side. Okay, Ian with Earthlink. Yep. I remember Earthlink. And then of course, AOL, right? Your parents, you know, it's funny, as I get older, I probably can relate more to your parents as far as some of the references that I may have. But AOL used to send out, first they sent out floppy disks, then they sent out CDs later on when the CD became popular, where they could get everybody to sign up for free and then, you know, start a subscription after that, $9.99 a month. So email has been around for a very, very long time. And by all indications, it's not going anywhere, right? I mean, one of the kind of backbones to our communication capabilities in an online class is messaging, right? Either through Canvas's built-in messaging or through email. I mean, it just makes our ability to share information with each other so much easier. All right, so I'm going to stop right here, and we'll take our first break. Let's go until 9 o'clock, so about 8 minutes from now, and then we'll come back and we'll continue looking at. Now that we know what email is, let's see what makes it tick. What's inside of email? You know, what are some of the technical characteristics of email? And then we'll finish our conversation by looking at what exactly are the email servers that are out there for Windows, Linux, and then the cloud. All right, so let's pause this video here, and then we'll come back at 9 o'clock. All right, well, let's get started again. So let me share my PowerPoint again. And boom, share. All right, so when we think of email, the typical user anyway doesn't really think about the servers involved with email, right? And this is true whether it's on campus or on premise or in the cloud, whether it's a cloud service or on campus email. So what makes it tick? Well, email systems have several components that are part of it that consist of various sections. So let me get to my slide here. So, and there's all kinds of protocols that work together. So first we need the mail client, right? Which is what the user connects to actually read and connect to their email. Then we have the SMTP server, which is the simple mail transfer protocol that does the sending of our email. We need DNS servers to actually know where to send it by name instead of by number. And then the mail transfer agent that communicates from one server to another server. And then where is it stored on either IMAP or POP servers? And then finally, the other email client on the other end to receive and view the communication. So there's a few things going on here. So here's a good illustration where the email is composed in the email client, right? They address it to whoever they're sending it to. It goes to the SMTP server, which looks through the DNS server and figures out how to get to the domain. And then the domain sends it to the mail transfer agent that will send it to the user's email address and their account. And then the recipient will grab it from there, either with IMAP or POP. POP3 is the current one. Okay, so all this occurs, and people just assume that IT has set all this up right. So in today's lab, you'll see that there's a couple things we have to make sure are in place in order for this to work. Okay, now the email gets sent by the client to the outgoing mail server via SMTP. And the SMTP server is like the local post office, which checks your postage and address and figures out where to send your mail. SMT works with DNS to translate the @domain.edu to an actual IP address. And then it's going to check the domain to make sure it has a registered mail exchange server on it. So one of the things we have to do in today's lab is when we build our mail server, we have to create a DNS record. So right click in the forward lookup zone, right click new mail exchanger. And then we put in the fully qualified domain name of our mail server, which for us will be mail.cnet.lab. Okay. So once that's in there, the domain DNS in Active Directory will then say any mail messages, I know who gets that, that's our mail exchanger. Okay, so and every domain has to have at least one MX record. Many companies will have multiple ones for redundancy. Okay, and then now that the SMTP server knows where to send the email, it sends it to the target domain's mail exchange server. This server is known as an MTA, or the mail transfer agent, and the MTA decides where to put the email. Now POP, which is the post office protocol, or IMAP, which is the internet message protocol, are used to retrieve the message and display it on the mail client. Now POP and IMAP, they do the same thing, but they function a little bit differently. So POP is similar to the regular post office, where you can pop in, grab your mail, and leave. And it doesn't leave, normally by its default setup is, it doesn't leave a copy of the message on the server. So when you pop it, you pull it off of the server and it goes into your mail client. So if I check my email at home and I pop my mail, whatever was on the server will be on my home computer. So then if I go to the office and I want to look at that message, it's not going to be available to me because it's on my home computer only. Now, that's the primary drawback, really, is that once you download a message, it's only available on that system. And today's multi-connected world, this is a problem, right? With sorting out where the email message is it on my home computer, is it on my work computer, is it on my iPad, is it on my phone? So POP can get pretty messy. So the better solution is IMAP, and most of our mail clients are defaulted to IMAP. So when we set up today's mail server, and we're going to use the client of Thunderbird, Mozilla Thunderbird, it will do automatically set it up with IMAP as the mail retrieval method. So IMAP is bidirectional. So whatever messages we read, they're still on the server. So now if I go home and I check my messages and there's an email from a student, when I get to the office and check my email, that message from the student's still there, because that's probably where I want to respond is, especially if it's a question pertaining to something, specific to a class where that material is probably in my office. So when you check your email on your phone, it's marked as read. So when you open your email at home, it shows that you've already opened that email message, right? So on our phone, on our computer at home, our computer at work, it's all available there. So like our Gmail, our web mail clients, they're using IMAP as well. Now, your outgoing and incoming mail is handled by two different servers. Now, a lot of times in today's lab, these two different servers are on the same machine. It's just part of the mail software, the server for the mail server software. So sending servers must have static IP addresses, and most ISPs block the standard SMT port, so home users cannot send email on their network. Why is this? Because of the massive amounts of spam eating up the bandwidth on our systems. So a home user with our ISPs, so like I'm on not Fios, Frontier, and my ISP gives my home router a dynamic IP address. It's not a static IP address. So if I set up a mail server on my home computer, on my home servers, and give it an IP address, that IP address is going to change, which means nobody is going to be able to send me email because my mail server is going to keep changing. And then the other thing they do is they block port 25. And the reason they do that is because there's so much spam. And we'll look at spam here in a little while. Okay. Now, what ports? So that's what makes it tick. That's the overview, right? With this system here, where it's composed, is sent, DNS, gets the MTA, and then the user grabs it. Okay. So let's talk about some of the protocols and some of the ports. And this is information you need to be well aware of. First off, SMTP is the Simple Mail Transport Protocol, and it uses port 25, TCP port 25. This port is typically blocked on a local network to prevent a machine from becoming a spam bot. So there are viruses and attachments that as soon as you open them, they turn your machine into a spam relay system. So if your local network allows outbound port 25, all of a sudden your machine starts spitting out millions and billions of email messages. Now there's a project that their goal is to eradicate spam from the world, right? Just like, you know, and they've been in the news lately, so I'll mention them, but this is for good things. The Gates Foundation, right, with Bill and Melinda Gates, they started their foundation with the goal of eliminating polio from the world, right? And, you know, that's one of their life missions from the Gates Foundation is to eradicate polio, right? The disease from the world. Well, Spamhaus has the same goal here. So let me open their website. So let me go. So if you go to spamhaus.org, it has all kinds of stuff going on here, but their mission is, with the 20-year history of vast internet data traffic visibility and protecting over 3 billion users, Spamhaus is an industry leader in real-time, actionable, highly accurate threat intelligence. So what is Spamhaus? If you go to About, you can see that their mission here is to get rid of spam around the worldwide internet. So they have been fighting this since 1998, right? So they've been around for quite some time, and they have the capability of tagging or marking messages as either spam or not spam on a scale of 1 is not spam, 10 it's totally spam, anywhere in between. Now, according to Spamhaus, the worst person in the world when it comes to spam is a user named Herbal King. And the Herbal King is located in India. So this Indian spammer focuses on replica, luxury goods, and pharmaceutical products. Next is someone in Hong Kong and someone in the Ukraine. So where does most of our spam? Well, the number one spammer, according to Spamhaus, is this user named Herbal King in India. Now, right away, you probably remember what we said last week about jurisdiction and how do you enforce the laws in one country in another. And it's going to be very difficult to prosecute a spammer in India, if they violate some rule in the United States. So, that's why spam is such a prevalent problem. Now, it is estimated that roughly 130 billion spam emails are sent worldwide per day, accounting for roughly 70% of all global email activity. So let's put it in terms of what we can really relate to. If you watch a 30-minute TV show and only 9 minutes of it is actual content, so the show itself, if it was streamed, it'd only be 9 minutes long if they took out the commercials. That's how much email is spam is, if it's a 30-minute show, only 9 minutes of it are actually the show itself. The rest is all unwanted advertisements. Spam in the US alone costs about $13 billion to manage it, right? With our spam filters, with our spam protocols, with our spam network devices that we have to incorporate. It's an unending barrage of information. And when you work in IT, you're going to get users that will send you, hey, I got a spam message today from this. I got a spam message from today from this. Can you block it? So you feel like you're the tail trying to wag the dog instead of the dog wagging the tail, right? It's like, okay, let me add this to our mail blocking. Let me go in and find this message and then mark it as spam. That way, all future messages will do that, but will have that tag and they'll get blocked by our filters. Now, the Philippines receives more spam emails than anywhere else in the world. So nearly 90% of all email into the country of the Philippines is considered spam. So I've asked around why that is, and I have no idea why that one country gets such a higher percentage, where the global, it's around 70%. So they're getting a lot more spam than everybody else. Okay, another protocol that we can use is secure SMTP, which uses a SSL and TLS encryption. Now, with the encryption, it's not anonymous, or it cannot be sent without it being signed on both ends. So this prevents spam by using SSL certificates and TLS certificates. And these protocols use port 465 or 587. POP3 uses port 110, and then IMAP uses port 143, and then secure IMAP uses port 993. Okay. Now, for us, when we set up a mail client, so let's say you get a help desk ticket that says, hey, can you go set up Juan's email on his workstation in the accounting office? So you go over there and Juan logs in, and then you say, okay, let's open Outlook, put in your email. Normally, the mail clients today will automatically look for the open ports. So when we set up Thunderbird today, we'll use the auto, and then if it gets stuck, we'll change the SMTP server and the IMAP server from .cnet.lab to mail.cnet.lab, and then that kind of bumps it in the right direction. Okay, so those are the ports. So now we know what makes it tick and what is it. Now let's look at the managing it. Okay, so congratulations. So let's start with a kind of a story here. congratulations, you just stepped into the most important job in your entire organization. No, it's not the CEO. It's not the #1 salesperson. It's not the janitor. It's not the person who makes sure fresh coffee is made, or even the one who prints out the monthly TPS reports, right? If you've seen Office Space, you know the reference. We're talking about the person who keeps the email system running. Now, obviously that's sarcasm. I don't honestly believe this. However, email is often the most visible application utilized by a company. Have you ever been to a concert or any kind of play or anything like that? And if it's done right, you probably don't even notice that there's a sound booth somewhere in the auditorium, right? If everything goes right, you don't even know that the sound engineers and the sound team, the technicians that run the sound equipment, you don't even notice they're there. However, as soon as you hear this squelch or someone's microphone's not on when they're talking, what does everybody do? Everybody turns and looks at the sound booth, right? That's exactly how IT is when it comes to email systems. When it's working, when it does what it's supposed to, people don't even realize that this is a server, that this is something that needs to be maintained, it needs to be set up, it needs to be configured, it needs to be, properly secured. All those things, they don't give it a second thought until their email doesn't work. And then they turn and look at the sound booth and say, what's going on? What are you guys doing? So that's where this kind of concept comes from. Now, in Windows, the king of the Windows Server platform is Microsoft's Exchange Server. Now, Microsoft's website describes Exchange Server as the following: get business email, calendar, and contacts delivered on your PC, phone, and browser with a simplified approach to high availability and disaster recovery, achieve new levels of reliability, and reduce complexity while protecting sensitive and confidential information. So that one paragraph there ticks all the boxes of we should really go by Exchange Server, right? So let's take a look at this link. And Microsoft has now moved their mail systems to the cloud. So with Office 365 and Microsoft 365 is what they call it now, it has the capability to move all your email into the cloud. So the ability to set up Exchange now is as easy as just setting up the user accounts. You have a file, so you'll say, okay, here are all my user accounts with their email addresses. You import it, and then you just point their client to the cloud, and everything works the way you want it to. Now, the beautiful thing about the cloud as your mail server, and I'll talk about this at the end, is now it's not your responsibility to maintain it. It's not your responsibility to wrestle with all the spam that comes in and out of your mail server. It's not your responsibility to update the server. That's now the cloud provider's responsibility. Now you pay for that, right? You have to rent it from them, basically lease it. You'll never own it, but you'll have a part of it with it in the cloud. So Microsoft released Exchange Server 4 in '96, and it's been evolving ever since. And Exchange replaced Microsoft Mail, which had existed prior to that. So that's why it started at version 4, because there was a Microsoft Mail 1, 2, and 3. So the first generation started in '96. The Exchange 2010, which was the last non-cloud-based version, it went through Exchange 2010 in October 2009. Let's see if this link works. So 2016, with Exchange, this is their latest version. And this article just basically says there's not a lot of changes between Exchange 2013 and Exchange 2016, and other than the fact that Microsoft is clearly and succinctly directing everything towards the cloud. Okay, so when you install Exchange 2016, it asks you to point it towards an Azure cloud server. So there's nothing. I mean, they're forcing you, if you're a mail server administrator or an Exchange administrator, you've got to learn the cloud. You've got to have the cloud technology expertise under your belt. All right. Now, Exchange is always on. It uses a building block model, which allows us to have better uptime, built-in monitoring, simplified load balancing. So it has built-in load balancers and reduces storage costs. Exchange is secure and compliant. So it has what's known as data loss prevention capabilities. And this is something that we can enable on our Exchange systems that will prevent a user from attaching a file, say an email attachment of, say, a spreadsheet that contains sensitive information. So if we turn on DLP, we can tell it, don't let this type of confidential information leave our network via email attachments. So that's a huge benefit from a security standpoint, you know, because we can set our firewalls, we can do all that and prevent all that stuff from getting out. But if we allow mail, and as part of the mail, it'll just go out through that. You know, it's like the old spy movie where they put somebody inside a box, right, like in a cardboard box, and they mail them to the country they want the spy to, you know, go get into, you know, England. So let's put you in a box and mail you to England. Then when you get there, just open the box and you're in the country. We don't want that to happen with our email. Now, the Exchange also keeps all our important data in one place by giving users an in-place archive with a native, well-integrated experience. Mobile devices policies let you create approved mobile device lists, enforce PIN lock, and remove confidential company data from lost phones. So with our Exchange system, we can set it up so if somebody has an email account installed on their phone, either their company phone or their personal phone, we can do a remote wipe automatically. So as soon as they report that phone lost, we can go just click a button in our Exchange management, boom, all email that was from their company email address will be deleted from that phone. So if there's anything on there that could, you know, have some security risk, it's neutralized and gone. Simplified deployment with custom instructions for installing or upgrading Exchange. Manage your organization efficiently, delegate permissions, and then move to the cloud on your terms with full deployment flexibility, whether we're on-premise, in the cloud, or a hybrid, which a lot of companies are still in the process of moving from on-premise to the cloud, right? And we've talked about this in this class and in other classes in the CNET program, is if you have something that works, you're not going to just automatically, well, the cloud's better, let's just scrap all that. Let's just throw away that investment and reinvest it. No, if it's working, you're going to use it. So if it's not broke, don't try to fix it. And a lot of companies have their mail systems that have been working for decades. And yeah, the cloud's better, the cloud's secure, the cloud's all this stuff, but it's still a cost factor. And, you know, the owner might say, well, if that works, let's stay with that until, you know, we absolutely can't anymore. Okay, so here's the front end for the Outlook web app, which is the OWA. And it's just a web-based client for email. Now let's look at Linux. Now, Linux is Unix in particular has been around a lot longer than Windows, right? So when we compare Windows solutions to Linux solutions, there's only a handful of solutions in Windows, but there's a lot of options with Linux. Now, Unix Linux contains the grandfather of all email systems, which is known as SendMail. And SendMail goes all the way back to the original ARPANET mail system that Tomlinson had, which was called DeliverMail. So DeliverMail turned into SendMail. And in 2001, which was just, at the height of the internet revolution, if you will, nearly 42% of the publicly reached mail servers on the internet sent their mail using SendMail. So that's a huge market share. Now, SendMail is notoriously difficult to set up for novice server admins, but once it's set up, it runs flawlessly for years or even decades. And SendMail is the mail transfer agent. So it's the back end of receiving mail, put in mailbox, and people connecting to it to get their email. Okay. Now, an alternative to SendMail is Postfix. In 2012, 23% of all publicly reachable mail servers on the internet ran Postfix. So Postfix has the caricature of the mouse delivering the email. So that's their icon. Now, a web-based mail system can also be created on Linux mail servers with and all of these systems, SendMail, Postfix, and Roundcube, Squirrel Mail, all these are free. They're open source. Whereas Outlook web app and Exchange is a paid service, and it's an expensive server. For a small company, just to buy the Exchange mail software can run close to $5,000 to $10,000. So it's an expense. So a lot of smaller companies are like, well, let's just use the free stuff, but it's a little more difficult to set up. Okay. So I always like this Squirrel Mail, where it shows this little squirrel, this little ground squirrel, and it says webmail for nuts, and it's run by the Squirrel Mail project. So that if you look at mail server projects, a lot of them will probably have either Squirrel Mail or Roundcube for the webmail solution. Okay. Now, it's possible to never set up a mail client such as Outlook, Windows Mail, Mac Mail, Thunderbird, or Eudora, because a lot of companies, they just use the web interface, right? A lot of people, when they get on the internet, so let me go to Google, and they go to their Gmail, and let me go to my other Gmail. So this is my email over there at LAPU, and this is all. If I want to, I don't have this on my phone. I don't have this on my Outlook. I don't have this on any of my other systems. If I want to check this, I just use the Gmail interface. And a lot of users, that's how they check their email, is strictly through the web-based system. So the presence of website-based email is the standard way most people use email anymore. So they go on their phone, they go on their device, and they check that. Now, the most used webmail site is Gmail, with over 425 million active users worldwide. So Gmail has a big chunk of email addresses. So if somebody were to come to you today and they were to ask you, say, to consult them on setting up their mail system, what would you recommend? Would you say, well, let's build a mail server on premise? Let's go with a Windows mail server, or let's go with a Linux-based mail server, or would you just say go to the cloud? What are some of the opinions out there? Anybody? Anybody there? Would you recommend that, say we're a small company, let's okay, so Frankie says let's use our Windows server. My personal opinion is, if I were to consult somebody, I would say let's go to the cloud. Let's just use Microsoft or Google or Amazon or whoever can support our servers and put it in the cloud. Now, we may do a Windows server in the cloud and set it up that way. But the nice thing about having Google do our email or Microsoft do our email is they then take care of all the mail administration. All we do is set up the accounts and set up the quotas in the mailboxes. Once that's done, now it's not our problem. So they're going to be in a much better position to manage and maintain the mail server compared to what we would do on our end. And especially when it comes to security, because securing your email is a very important part of our security strategy. All right. So let's wrap this up. So what did we talk about today? We looked at the history of email. We looked at what makes it work, right? With the various components. We looked at ports and protocols. Then we looked at a Windows mail server, Linux mail servers, and then webmail. All right. So that's all there is to today's lecture. There's not a lot of information here. There's a little history and stuff that we got through, but you know, it's not that complicated. All right. So let's take our second break here. I know it's only 9:30, but let's take a short break, and then we're going to jump right into the lab. So it's 9:37 now. Let's come back at 9:45, so about 8 minutes from now. And then I'm going to talk about the lab, and then you can start working on the lab as well. So let's come back at 9:45, and then we'll jump into the lab. Okay. All right, so let's take a look at what we're going to do in today's lab. And let me share my screen so you can see what's going on here. So here's my screen over here. You can probably see week 13. And if you go on to lab 12, and here's the lab write-up. So what we're going to do is we're going to add the killer app, right, which is email, to our system. And we're going to build a new mail server using Windows 2019. But before we do that, you are going to need to make sure you have these VMs from Lab 9, which was in week 10, so a couple weeks ago, 3 weeks ago, because we did PowerShell, then honeypots, and then now we're on to Lab 12 here. So you need Active Directory, DHCP, our router in Windows 10. So we're going to connect, and keep this in mind for later. We need to access that, but we need to add internet access to our router. So let me show you what that's going to look like. So we need to come into Guacamole and log in. And then connect with our Authy. Boom. Okay. And then when we're on our server with our RRAS turned off, go into the settings, and you should have LAN A, LAN B, and then what we want to do is add another network adapter and connect it to our Intel network. Okay, so that's the Intel I210 gigabit network here. Okay, and once we have that, then what we need to do, and now I've already done this, but then we're going to come back in and start it up, go to the Network and Sharing Center, and you should have 3 networks. Hopefully you named them LAN A, LAN B back in lab 10 or lab 9, and the local area, lab 10, sorry. And then the local area connection, rename that new one to internet. Now, if you come into your server and click on, with it running, click on internet or networking tab on the bottom, you'll see this IP address for LAN A should be 192.168.1.1. LAN B should be 192.168.2.1. And then LAN, the internet, which is the Intel, should be a 10.29.72. something address. And that's how you should be able to go in there and check them. And you want to make sure that you name that one internet, because we're going to need that later on. So then we're going to disable routing and reconfigure it with network address translation. Okay. Then we're going to go to DHCP and modify our DHCP so we have an internet facing DNS server, because right now we only have 192.168.1.3 as our DHCP, and we need that to be able to get on the internet. And then we're going to restart that, and then we're going to go to Windows 10.1, and on Windows 10.1, make sure this has to be set to LAN A. So this one only has one adapter, which it should only have one. Last week we had it on the Intel. This week we need to make sure it's on LAN A. Okay, so make sure that's set properly. And then it should get internet access to it. Okay, so once you have that set up, you'll have that. Then the rest of it is just creating the Win Server Mail virtual machine. So we're going to do a new differencing disk. At this point in this class, you should be able to do that in your sleep, right? We've done this many, many times now. Okay, new differencing disk, and then we're going to create a new VM based on that differencing disk. So remember, the differencing disk will be based on the Win Server-parent hard drive. Okay, if you forgot how to do that, go back to lab 10. That's where we did it the first time. And we're going to call the VM Win Server Mail, give it 4 gigs of RAM, use the hard drive that we just created up here, and then connect it to LAN A. And then we're going to start up the WinMail server, log in using CNET58 and the CNET58 as the password. That's not correct. We're going to log on as administrator and all that. And then you should have 192.168.1.0. You'll get an IP address from our DHCP server. So all these need to be running. Active Directory is running, DHCP is running, RRAS is running, 10.1 is running, and Win Server Mail, once you have it set up, it'll be running as well. And then I ask you to tell me what the IP address is. It should be on 192.168.1. something. If it's not, check that you're connected to the right networks, right? Go into your VM settings and make sure that's there. And then we have to change the mail. We need to change the host name from Win something or other, all ugly. And we're going to change it to mail. Then we're going to attach that server to the domain. Okay. And then once it's on the domain, now, if you go in the video, I show where it won't attach to the domain, and I open a command a command prompt and I try to ping mail or CNET.lab and I get a response from the internet. If that happens, go into your WinServer-mail and change the DNS to a manual where it only uses 192.168.1.3. And then attach it to the domain and then undo that. Okay, that's just a temporary fix to get that there. And then we need to edit the group policy edit, which we'll have to do on the network. Okay, so you'll once you attach this to the domain, and I thought I updated this. Anyway, I'll here. So I say, if you get an error, perform step 3. So right here, expand the computer configuration on GP edit. Go to your domain, your Active Directory computer, and perform the same steps over on the Active Directory. Because once we attach it to the domain's default group policy overrides our local security policy. So if you get an error when you try to go to the file share, go to the Active Directory group policy and edit it there. And then you'll have access to the share, CNET58, CNET58, and just copy the hmailserver.exe to your desktop. And then before we install that HMail, we need to set up this .NET framework feature. And again, all of these steps, I'm just kind of highlighting them here. They're in the video. So go into the week 13 video and the lab video, and you can watch me do this, and then you can just follow along. Okay. And then once that's done, we're going to install HMail server, give it a cnet.lab. We're going to create a couple user accounts, user 1 and user 2. So click on accounts and give it the name, user 1, user 2, and the password. And then we're going to update DNS in our forward lookup zone. So here's where we create that mail exchange record, the MX record for mail.cnet.lab. Then we're going to go to Windows 10, install Mozilla Thunderbird, and configure it. And really only have 2 questions in this week's lab, which basically I just ask you to, once you've sent an email from user 1 to user 2 and from user 2 to user 1, paste a screenshot of your sent email from user 1. So just come into this user 1, click on sent. Once you send it, it will say sent. Take a screenshot of your sent mail for user 1, then do the same thing for user 2 and paste it in here. And that's it. That's all I'm going to really evaluate. If you can do that, you've done everything else right. And I show you how to do that in the video. Okay. So that's this week's lab in a nutshell. And again, there is a recording of this. I went into the system here. So let me close this. And if you go to week 12 or week 13 videos, I already have the video for the lab posted. So you can just watch this video here and you can watch me walk you through the video. So here you go.
Hi, I want to take a few moments here and talk about our lab 12, which is
so you can watch that on at your leisure and you can enjoy that. All right. So while you're working on all of this stuff, I'll be on Zoom here. If you have any specific questions, other than that, just do today's lab and submit it on under week 13, submit lab 12 here, like we have been, and you're well on your way. Okay. So if you have any questions, just ask me and I'll be here until I have a meeting at 2 o'clock today. So we'll go until 2 o'clock. And then if you have questions afterwards, just send me an email and we can either meet on Zoom or I can help you over email. All right. Any questions? So RAS isn't starting up, says failed to change state, operation failed. Okay, all right, go ahead and share your screen, Frankie, and I'll take a look at that. I'm gonna stop the recording.